Good morning, students. We are continuing the chapter gravitation. Previously, we have studied about the Newton's law of gravitation. What was the statement of the Newton's law of gravitation? Every object in this universe attract another object with some force, which is directly proportional to the product of their mass and inversely proportional to the square of their distance. Now, today we are considering the next definition part, that is, what is the meaning of the free fall. Now, what is the meaning of the free fall? Whenever object fall towards the earth only under the force of gravity. When an object, what we are doing, we are just dropping the object and that is falling freely under the gravity. So that body is said to be under the free fall. Okay. So whenever an object, when we are just throwing, okay, then it will freely fall under the gravity. That will be called as the free fall. Now the next term it is there. What is the meaning of acceleration due to gravity? The acceleration with which the body fall towards the earth due to the earth gravitational pull or the force of gravity. Okay. Now within which the what is the meaning of acceleration? It means when the object it is falling, okay, it is falling freely under the gravity due to the acceleration, and that acceleration due to gravity it is denoted by small g. So acceleration due to gravity, we can say that it is denoted by small g. And when the object it is falling towards the earth due to the earth gravitational pull, which is the 9.8 meter per second square. So what is the value of the small g? It is 9.8 meter per second square, or we can consider it as the 10. Okay. So acceleration due to gravity, the acceleration with which the body is falling towards the earth due to the earth gravitational pull, it is called as the acceleration due to gravity. Next, if we see the relationship between the small g and capital G, now as per according to the Newton's law of gravitation, we know that F equal to G mm upon r square. According to the Newton's law of gravitation, every object in this universe attract another object with some force, and this force is directly proportional to the product of their masses and inversely proportional to the square of their distance. Okay, so we are considering F equal to G mm upon r square. Here capital M is the mass of the earth and small m is the mass of the body, and r is the distance between them. According to Newton's second law of motion, we know that F equal to m into a, but here acceleration is in the term of the gravitational acceleration, so we are taking it as the small g. Now since if we see that this is the equation number 1, this is the equation number 2. Now in both sides, if this is the force is there, they both are equal, so we can equate both them. We can write here mg equal to g mm upon r square. So this m and this m, it will get cancelled off, and finally you will be getting g equal to gm upon r square. Okay, so what we have done in this, according to Newton's law of gravitation, F is the force between them and the distance between them. So F equal to g mm upon r square, we have to consider it as the first equation. Second equation, F equal to Newton's second law, F equal to m into g. So by first and second, this both the sides are equal, so we can write down mg equal to g mm upon r square. This will get cancelled, and finally you are getting g equal to gm upon r square. Now we have to consider the values like mass of the earth. Capital M is there, is 6 into 10 to the power 24 kg. Radius of the earth, that is 6.4 into 10 to the power 6 meter, and gravitational constant, we know that 6.67 into 10 to the power minus 11 Newton meter square upon kg square. So when you substitute these values, g equal to in the place of g, you will write 6.67 into 10 to the power minus 11. In place of mass of the earth, we will write 6 into 10 to the power 24, and in the place of radius, you will be writing 6.4 into 10 to the power 6 square. So on solving, you will be getting 9.8, and approx this value can also be taken as 10. Okay, so 9.8 is the acceleration due to gravity. So what we have studied, the two topics today we have studied, that is the free fall. When the object is falling freely under the gravity, that will be considered as the free fall, and when the object is falling, it is moving freely under gravity, and the value of the gravity, it is 9.8 meter per second square, or 10. Now to derive the relationship between small g it is the gravitational acceleration, and g is the universal gravitational constant. So we have to take two equations here. One is the Newton's law of gravitation and another is the Newton's second law. When you are taking Newton law of gravitation, we will be writing F equal to G mm upon r square. When you are taking Newton's second law, F equal to mg. So on equating, this m, small m will get cancelled off. So when the question it is asked is, suppose the body it is, if a question it is asked, the mass of the body it is suppose 10 kg, what will happen if you are going to the another place? Will it affect the gravity? So you have to write down that no, the gravity never depend upon the mass. We see that this is get cancelled off. So gravity never depend upon the mass of body. Okay, it always depend upon the mass of the earth and the radius of the that particular place. Okay, so G is equal to Gm upon r square. This m get cancelled. So the gravity does not depend, it is independent on the mass of the body. Okay, because the mass always remain constant. Now with these values you have to learn: mass of the earth 6 into 10 to the power 24, radius of the earth 6.4 into 10 to the power 6, and gravitational constant. So all these values when you are learning, and when you are keeping in this formula Gm upon r square, you will be getting this 9.8 meter per second square.